Hey guys, and welcome back to another video on the channel. In today's video we're going to be taking a look at the 2023 Specialist External Exam Paper 2 Question 6. As you would notice with all the videos on the channel, I've started splitting them up into the individual videos. That way, for each question. So that way if you only struggle with a certain type of question, you can go watch that on the channel. The full exam video is still up on YouTube. The link is in the description below. If you guys need a Specialist External Exam bundle pack, the link is also in the description below. And at any point during the video, if you guys have any questions, just leave something in the comments and I'll try my best to answer it. But otherwise, let's get straight into it. So question 6. Two coplanar forces of magnitude 12 newtons and 10 newtons act on an object in the direction shown. Okay. Determine the magnitude of the resulting force acting on an object. So here, what we've got to understand is pretty much where the object is going. So if it's got 12 newtons going downwards and 10 newtons going this way, the object is most likely going to move in a direction somewhat like that, okay? Or maybe somewhat like that, okay? The point is it'll move, so it'll move north, east, south, west. It'll move southeast roughly, okay? Now, how we actually answer this question is we've got to break it up into components. So we'll just call this F1 and we'll call this F2. So F1 only has a vertical component, so we can break it up into a force vector. So F1 will be 0 in the x direction and 12 in the y direction. However, the direction matters, so we'll say it's a negative 12 because it's a downwards force. Okay. Now here, F2 is given in polar form. We've got to convert that to component form to make a fair comparison. So the x force here will pretty much be 10 cos of 22. So 10 cos of 22, and this is where you'll need your calculator for this bit here. Then for the other bits, because it's a downwards force, it'll also be negative. So it'll be minus 10 sine 22j. And if you're wondering where I got these guys from, I just broke this up into a triangle like this. That's 10, that's theta. So that side here would be 10 sine theta, and this side, not sine, that would be cos theta, and this would be 10 sine theta, because that's your opposite, that's your adjacent, that's your hypotenuse. Now, this is the part where you would need your calculator for this question here. You have to work out what those trig bits are there. So here, 10 cos 22 gives us, now make sure you are, I just made the mistake there, make sure you are in degrees for this bit here, otherwise you'll get incorrect values. So F2, that's 9.27i, and then here, 10 sine 22, so this bit here is minus 3.74j. So here now we can do a fair comparison of the forces. So F1 and F2, we can add them together. Now here nothing is really going to change because the x component just still stays as 9.27i. So this is F1 plus F2. And then for the vertical components, because they're both negatives, you can still just add them together and work out roughly how big that is. So it's minus 15.7.4j. Now they said calculate the resulting force. So that pretty much means the magnitude of this guy here. So the magnitude of the force F1 plus F2 is pretty much just finding the length of this vector, which is just an application of Pythagoras' theorem. So you square root and then you square each of the components. So 9.27 squared plus negative 15.74 squared. And then you chuck that into your calculator. So 9.27 squared plus negative 15.74 squared. So here this gives us around 18.266. So we can round that to 18.27 roughly, and D is our correct answer. Okay. Is this a hard question? No, not really. If you're pretty good at vectors and forces, it's a pretty easy question. The only annoying thing is perhaps calculating these bits. If you left them in radians, that might have affected it. If you have any issues with this question here, you may need the Specialist External Exam bundle pack. The link is in the description below. But otherwise, if you have any other questions about this guy here, leave something in the comments and I'll see you in the next video.